STP or spanning tree protocol. In this video I'm going to talk about again STP, and after that I'm going to talk about some of the features in the STP, for example port fast, BPDU guard, a cost of interface, port priority, and some other topics. And finally we will talk about the RSTP or rapid spanning tree protocol. First, let me to start to talking about the STP with port fast. You know that in previous video I explained the port fast feature. Here I'm going to review the port fast feature. After that I'm going to add one feature to the port fast. You know that in STP we have three different kinds of the topology change. The first is direct topology change. Let me to write here direct topology change. We can say we have three STP topology change kind. Okay, the first three types. The first type is the direct topology change. Direct topology change. You know that in direct topology change, for one interface from the block state should go to the second state, listening state, and after that learning state, and after that forwarding state. And you know that it takes about 30 seconds to enabling one interface from block state to forwarding state. This is the first type of topology change. But also we have another type of topology change in the STP. We call it indirect topology change. Okay, indirect topology change maybe need more time to be change from the block state to the forwarding state. You know that when we are experiencing one indirect topology change, first we should wait about 20 seconds, and this is the max age timer. After that we can convert the blocking state to listening state. Because of that, let me to write here max age. Okay, max age timer, then block to listen. You know it. Okay, because of that finally we will experience 50 seconds. I explained all of these features. Because of that I'm not going to delve into the detail of direct and indirect topology change. And also you know that we have another type of topology change. We call it insignificant topology change. Insignificant topology change is the topology change that in this type of topology change we don't need to wait for listening or learning or max age. For example, when you are connecting one interface to one interface of switch to a computer, because the computer cannot create a loop, because the computer adding does not need to change the MAC address tables in all other switches. Okay, because of that we don't need to wait for the maximum age timer, or also listening or also learning. Because of that you can configure this interface as this interface changing from the block to forward as insignificant topology change. The switch cannot understand automatically that this interface connected to one PC. You need to configure this interface as one insignificant topology change. Okay, interface. This feature is calling port fast. Okay, port fast means a port that does not need to pass from the list blocking state to listening to learning and then forwarding. In port fast we are bypassing the port from the block to forward state. We can say we are jumping from the block to forward state. It is so useful when you are connecting one PC or computer to one port of the switch. Okay, let me to show you how we can configure the port fast. I implemented the port fast in previous video for you, but let me to say that the port fast is the Cisco proprietary feature. Because of that you don't have this option in the standard STP and also in other brands. How we can configure one interface as port fast? We have two methods. The first method is configuring the port fast interface by interface. A spanning tree, the command is so easy. A spanning tree port fast, that's it. Okay, also if you want, you can enable the port fast feature globally on all access interfaces with this command: spanning tree port fast then default. This command means on all access interfaces, only access interfaces, please enable the port fast. Okay, we implemented the port fast and you saw the port fast feature, but let me to introduce another feature that is related to the port fast. This means in most cases we are enabling this feature with the port fast. Look at here, the name of this feature is the BPDU guard. Okay, what is the usage of BPDU guard? Let me to review the function of the BPDU guard. You know that when we are connecting one PC to the switch, okay, this PC cannot create a loop. Because of that, we are configuring the interface as the port fast feature. Let me to say that it is possible to connecting one switch to the port fast, maybe for example intentionally or unintentionally. Assume that this new switch has a lower priority in compare with the root bridge. For example, the priority of this switch is 4096, or maybe the priority is same but the MAC address is lower than the for example MAC address of the root bridge. Because of that, this switch will convert to the root bridge and it can change all of the topology. This means that in port fast links we have maybe we encounter with some problems. When you are configuring the port fast, actually you are disabling some of the protectional features of the STP, such as the listening. Okay, an attacker could connect a switch to one of these ports, one with the low STP priority value, and become the root switch. The new STP topology could have worse performance than the desired topology. For example, if you use here one switch, maybe this 1 gigabit per second link, for example, blocked, and other links 100 megabit per second and now is working, and this is not good because the more performance link now does not have any function, but with the lower performance now is working. Because of that, here we have one consideration about the port fast. When you are enabling port fast, actually you are disabling some of the protections of the STP, and one of the problems that may be occur is the attaching one switch to here switch or hub or some other devices. This is the first type of risk that maybe we encounter with it. Also, maybe we are experiencing another type of risk. Let me to talk about that. Here we have a switch, okay? Maybe an attacker connect the switch to one port of this switch, okay? This is the attacker switch, and connect one of the port of this switch to a port fast and other port to the other switch. For example, here now we have loop. You know that the ports of the with the port fast capability automatically should jump from the block to the forward state. Because of that, when you're attaching a switch to two switch, both of these two interface without passing the listening or learning state should change its states to the forward, and now we have a loop. Okay, and here maybe attacker can send multiple frames into the network, okay, from its computer, and because of that we are experiencing the degradation in the performance or maybe outage of the network. Also, we have another type of risk. For example, users could innocently harm the LAN when they buy and connect an inexpensive customer LAN switch, okay, one that does not use STP. Such a switch without any STP function would not choose to block any ports and could cause a loop. Because of that, here we have some risk with port fast. Port fast is a good feature. You need to use port fast in your networks when you are connecting the switch to the computers, but here we need some protection mechanism for example, protecting the STP topology. Okay, how we can protect the STP topology? In STP we have some tools, but in CCNA we will not talk about all of the tools of the STP protection. Only one of them